In the previous video, we looked at components and how they varied from normal bodies. One thing that we saw was that components could be moved around since they have their own origin. In this video, we are going to go more in depth about joint relationships and motion. To start, create a sketch of a square and extrude it as a new component. Make it 50 millimeters by 50 millimeters. Unground it from its parent, which is the overall design, so we can move it around. Before this, bodies were completely dependent on their initial sketch. This means that their location only ever depended on where their sketch profile was. Now, we can have components move around, because their position is technically unconstrained, in a way. Since their position is now undefined, in order to work with them and build off of them, we need to define their position. This is really easy to do, and it is called position. When we move this body around, we will see a new icon show up in the top right corner. The new tool is called Capture Position. By pressing the Capture Position button, all components within our design will have their positions recorded in the timeline. Let's see what this looks like. If I press the Capture Position button, nothing happens. But if you look at our timeline, you will see a new icon pop up. This is the Capture Position icon, and tells us that we have captured the position at this point. If we edit the Capture Position button by double-clicking on it, we will enter the Position workspace. We cannot do much within this workspace, but it allows us to move around our object, and movements within here will be finalized when we finish the position, and that will be shown in the timeline. Here we can learn about the Move and Align tools. The Move tool, which you can find by pressing M or this button in the top left corner, allows us to move around our object. There are various types of move that we can use, and we can also select specific distances. Start by clicking on the object you want to move. Here, we can select actual X, Y, and Z distances to move, as well as X, Y, and Z angles to change. You can also select translational movement to just do actual translational movement, or angle movement, in which you have to select an axis. The default version is Free Move, which allows you to do all of that with these different sliders and pan features. Press OK. The next tool, Align, is very useful when working with assemblies. It allows us to align parts of faces, edges, and points with other parts in our workspace. Press the Align tool in the top left corner. Try hovering over a face. You can see that it has different starting points that we can work off of. If you press and hold Control while hovering over a face, you can lock your cursor, which helps select which part you want to select. Turn on the origin and select one of the corner selections by holding Control. For the To function within the Align tool, we are going to select on the origin. We can see that it will automatically align that bottom corner to the origin. We also have other tools we can use to help us get into position. Flip and angle. When we align faces, it makes the faces coplanar, such as this. You can't see it. Let me do it like this. When we align faces, the faces become coplanar, sharing the same plane. This means that the object will simply move in that direction until it becomes coplanar. This allows us to align our faces onto the same plane. We can also do this with vertices as well. Once we find a position we like, finish the position and it will be recorded in the timeline. Here is aligning vertices. And we can also use the flip function to change which direction it is aligned in. Flip will change the plane that it is on. Flip will change the side that it is on, and angle will change its actual position. You can't really see it because we're working with a cube, but if this had a different shape, by pressing this angle tool, it will flip the cube 90 degrees each way. It's flipping it like that right now, you just can't see it because it's a cube. Press OK and press finish position. You will see that this new icon shows up in the timeline. This means if we wanted to go back and edit it, we can always edit that position. Once you press finish position, that position is recorded in the timeline. Whenever we want to make a new sketch or object within our design, Fusion is going to ask us to either define a new position or revert back to the last position captured. If I move this position, but don't capture it, and go to make a new sketch, Fusion is going to give me a new dialog. Either revert the position back to the previous position we made, which is this position, or capture a new position before we create our sketch, which you can see by another capture position showing up in our timeline. The next thing we're going to start learning about is joints and movement. To start, if there's a body that we don't want to move, we can pin it in the browser. Pin this component by right-clicking and clicking Pin. This locks its position and means that we cannot move it. The pin will always pin it relative to the last current capture position for this component. So if I delete this capture position, you will see that it is still pinned, but it is pinned compared to this capture position. Go ahead and delete everything within your timeline to get ready for the new joints. Create a new sketch with a 50mm circle and a center rectangle that is 100 by 100. Finish the sketch. Press E for the extrude tool, select the operation as a new component, and start on the center sketch. Make this center circle extrude 100. Go back in and turn that initial sketch on. Extrude this by 50. Make sure the operation is new body. Now we'll see that we have two components, but one of them is grounded to the parent. Go ahead and unground this so we can move all of the positions. Test it by dragging them and press Ctrl Z to go back to the original position. We are going to pin this inner cylinder. Pinning it shows up in our timeline and means that it won't move. If you want to unpin it, you can either delete that current pin or click the unpin feature, both of which show up in the timeline. We are now going to skip over the other joint features and go to the as-built joint. As-built joints take in the current position of the components for their joints. Click on the Assemble tab and scroll down to the as-built joint. Now, we're going to select our two components. Select the inner component and the outer component we just created. We are now going to see different motion types pop up. The starting joint normally is rigid. This essentially locks the two components relative to each other. If you click Preview Motion, you will see both of the components vibrate around, but they stay locked to each other. If you press OK and try to move the second component, you will see that it doesn't move. It doesn't move because it is locked relative to the initial cylinder, which is pinned. Undo this joint by deleting it. Create a new as-built joint with both of them again. Change the motion type from rigid to revolute. Revolute is a rotate joint. We are going to create a new revolute joint with the center origin snapped to the top of the cylinder. When we do this, we can see new measurements pop up called the motion joint limits. We can select a minimum and a maximum joint limit. For the minimum limit, we're going to set 0 degrees, and for the maximum limit, we're going to set 90 degrees. You will then see our joint will basically show how far it will slide or spin. We can also flip this and go the exact opposite way. If you click Preview Limits, the joint flag is going to start moving back and forth. This simulates the motion of the joint. It is difficult to see because this is a cylinder, but because the inner cylinder is locked, it's going to have the outer cube rotate. Click OK. Now we can drag this outer cube and we can see its position. We can see that its motion is locked in that 90 degrees. If we go in and edit that and click Flip, we will see that it's locked to that 270 degrees. We can also double click on our joint and rotate it, or type in a specific degree measurement we want. We can also see in our timeline a new relationships folder showed up. This folder will have all of our joints within it, such as our new joint that we just made. If you edit it, you can also click on Drive Joints. Here you can edit the joint once again. We're going to learn a new joint called the slider joint. Right-click in the timeline, the joint we just created, and edit it. Change the motion type from revolute to slider. We can now see that the joint will slide up and down in that slot. We can also select motion limits for this, such as a minimum and maximum. For the minimum, I'm going to set -100, and for the maximum, I'm going to set +100. We can then preview the limits to see how this will slide in the slot. Press OK. We can now drag the slot up and down to see its motion. And just like the revolute joint, we can double click on it and select specific measurements, or we can right click on the slider joint that is now in our relationships folder, and we can click Drive Joint to input specific measurements. We aren't going to go over any more joints for now, as they aren't as important as revolve, slider, and rigid, but there is one additional tool that is extremely useful for large assemblies. Delete the joint as well as the pin and go back to the Relationship tab. You will see this joint called Rigid Group. Rigid Group is essentially just the rigid joint, except we can select as many components as we want, such as more than 2. This then keeps them relative to each other, and is really nice for large assemblies, especially for keeping fasteners together within robotic parts, claws, etc.